Greetings and salutations. Welcome to part 2 of polynomial functions. Today we are going to look at polynomial long division. This is all sorts of exciting, and this is part of our quest to eventually be able to graph given polynomial functions. We're going to need to eventually be able to factor these things, and part of factoring is knowing how to divide. Right? They are very inextricably linked. In order to divide a polynomial, here's how we're going to do this. Now, things worth noting. We do need to make sure that there's a term of every degree from 0 up to whatever the polynomial's degree. So this one over here that we're looking at, highest one is 2, and then there's a term with 1, and there's a term with 0. So this one's good to go on that regard. And then it's arranged by descending degree, 2, 1, 0. Super duper. This thing is ready to go. This is how we do this. We'll set it up for long division, sort of similarly to how you might have seen long division way back like 7 or 8 years ago or whenever it is you learned long division of numbers. Whoop. With that part under these old division-y bars, and then our divisor out here. Now when we look at what goes into what, we're always looking at the x to see how much it goes into any particular term, and then the 5 will just come into play with multiplication. So for startsies, I look at how many times x goes into 2x squared. So if I take 2x squared, divide by x, I will get 2x. What I do next is I multiply. I'm going to multiply 2x by this entire term of x plus 5. And that's going to get me 2x times x is 2x squared. I mean, these are a match, which makes sense. And then 2x times 5 is 10x. So just a note there, that was 2x being multiplied by x plus 5. What we're going to do this next is actually subtract. So I'm going to subtract all of this from the line above it. And that'll get us, well, 2x minus 2x squared minus 2x squared is 0, which we don't really need to write. And then 13x minus 10x is 3x. So that step is done. To proceed, we're going to be dropping this. Where do I want to drop this color? At 15 will come down here. But what goes next up here? We're now going to be looking at this 3x and still just this x. So again, it's always just this x that we look at when we decide does it go into our next term and how many times. X goes into 3x 3 times, because 3x divided by x is 3. And now for our next step, we're going to multiply this 3 by the entirety of this x plus 5. And that's going to give us, so 3 times x gives us 3x, 3 times 5 gives us 15. And again, we got that line because that was 3 times x plus 5. Next thing we're going to do is subtract again. 3x minus 3x is nothing. And 15 minus 15 is also nothing. So we get a remainder of 0. This thing happens to divide quite evenly. And if we want to double check our answer, well, we could always take our quotient, multiply by that divisor, and make sure we get our original back. In a case like this polynomial is a quadratic, so it is something that we should be able to factor. but we're also going to be playing with polynomials that are of higher order or higher degree, ones that we might not immediately know how to factor, maybe not right now, but we will as we go through this unit. So this can be a little bit of a doozy. It's a little bit weird to get used to, and honestly it takes a fair amount of practice just to get a real feel for it. But hopefully you can see the parallels between regular long division and polynomial long division. Right? Feel free to skip over these next couple minutes if you want, but if you had something like, I don't know, 109 and you're dividing that by, oh, what's a good number these days? 6. You can say 6 goes into, well, it doesn't go into 1 at all. It goes into 10 once. 1 times 6 is 6, right? You'd be a little bit of subtraction. 10 minus 6 is 4. You'd bring this 9 down over there. And then you'd say how many times does 6 go into 49? And you'd be proceeding from there. 8 times 6 is this. You'd be subtracting again. So you get 18 with a remainder of 1. So these same kind of processes get involved with polynomial long division. Any boops. Feel free to try the other ones on your own if you want. I think there's only 2 on this page. Yeah. But if you want to follow along with my process, because I'll be describing it the whole way as I do it, feel free to absolutely do so. Funky thing about this next one, even though it's degree 3, that highest degree term isn't first, and that violates this rule over here. So we need to make sure that this thing is arranged and that there's a term of every degree. So when we plunk this thing into our little dividey bars, we know our highest degree term is 2x cubed. Next we need our number of x squareds. Fortunately we've got that. There's 3x squareds. Then our number of x's, but I don't see any x's anywhere in here. There's no straight linear terms. So we're going to say that there are 0 x's. And then our constant term, finally, how many x to the zeros do we have? We have 5 of those. So this is how we've accounted for that there is a term of every degree and that they are also in descending order, 3, 2, 1, 0. Absolute necessities for this to actually be able to proceed. And then with that being done, plunk that there, and we're saying dividing by x plus 1. Again, as I do this, I'm taking a look at just this x and how it goes into each next term. So x going into 2x cubed. For that, what color did I use? Oh, it's still purple. X goes into 2x cubed, 2x squared times. For multiplying, I'm taking this 2x squared and multiplying it by the entirety of this x plus 1. So 2x squared times x gives me 2x cubed. 2x squared times 1 gives me 2x squared. Then I will be subtracting this thing. And what that gets me, well, 2x cubed minus 2x cubed is nothing. Negative 3x squared minus 2x squared is negative 5x squared. So that step is done. As we proceed to our next step, we're going to drop that piece down. So we have our 0x right over there. And as we figure out what to next place here, we're going to be checking out negative 5x squared divided by x. Negative 5x squared divided by x is negative 5x. And then we do our multiplication step, which is again this entire thing being multiplied by that entire thing. So negative 5x times all of x plus 1. Whoopsie daisies. So negative 5x times x is negative 5x squared. Negative 5x times 1 is negative 5x. And now I go to the subtraction step. Negative 5x squared minus negative 5x squared is nothing. 0x minus negative 5x squared is positive 5, or that's not 5x squared, it's regular 5x, my bad. But it's positive 5x. So do be very careful in that. That's a very common place that I see errors being made, is that we see a 0x and a negative 5x and maybe put a negative there. Whoopsie daisies, don't forget that subtraction is the operation that's happening. Any poops, that part is done. We can now take this last 5, drop it down. For the final little bit of this, and asking what happens if we take this leading term here and divide it by this leading term there. 5x divided by x is 5. We can do our multiplication step. 5 times x plus 1. Well, 5 times x is 5x. 5 times 1 is 5. And then we do our subtraction still. 5x minus 5x is nothing. 5 minus 5 is also nothing. Oop, did I do a color change? Silly-a-thide. Whatever. I did it above too. So this thing is done. If we need to state the answer, the result is color, sure, that color. The answer is 2x squared minus 5x plus 5. If you want to just have that particularly boxed off. I'm going to do this next one with full description again as I go through it. So if you want to play this video at 2 times the speed, see what happens to my voice then, go for it. And then as we go into the answer, the examples on the next page, I won't be breaking it down quite as much. In any case, as I set up the dividend here, I've got 6x to the 4 minus 4x cubed plus 9x squared. Be careful, there's no straight up x term, so there are 0 x's, and then minus 4. And we're going to be dividing that by 3x minus 2. Just going to keep my work a little bit sorted here by throwing a random line in between. Okay. So a dividing step, my leading term here being divided by my leading term there, which gets me 6x to the 4 divided by 3x is 2x cubed. And now multiplying 2x cubed by the entirety of 3x minus 2 will get me 6x to the 4 minus 4x cubed. Well, that's exciting. Our subtraction step. This minus this is nothing. This minus this is also nothing. That was exciting. And then we drop this down. If you want, we can say that we have, here's my eraser tool, not just 0, but 0x cubes, because this next one is in terms of x squared. So we're maintaining that descending degree business. Dividing again, taking 0x cubed, our leading term there, dividing by 3x, our leading term there. And, well, 0x cubed divided by 3x is just going to be 0x squared. And as we multiply that by everything, 0x squared times 3x is 0x cubed. 0x squared times negative 2 is 0x squared. We're going to subtract this whole thing. Whatever, pink line now. Which is, this in this case, going to give us that. We drop the next term to attach over to it. Again, taking this leading term, dividing by this leading term. And 9x squared divided by 3x is 3x. That's a little far over. and going to multiply this 3x by this entire divisor. So 3x times 3x is, in blue, 9x squared. 3x times negative 2 is negative 6x. And we are subtracting that. As a result, 9x squared minus 9x squared is nothing. 0x minus negative 6x is positive 6x. And now here's that last drop down. And our last bit of checking this lead against that lead. 6x divided by 3x is 2. Taking this 2, multiplying by the entirety of this 3x minus 2 gives us stuff. 2 times 3x is 6x. 2 times negative 2 is negative 4. We are subtracting this entire thing. And in this case, that gets us 0. So our answer in this case, when we take 6x to the 4 minus 4x cubed plus 9x squared minus 4 and divide it by 3x minus 2, we get an answer of 2x cubed plus 3x plus 2. That's this one done. We're not writing this 0x squared because that would be considered an unsimplified final answer, because 0 times anything is 0 and 0 plus anything gets completely wiped out. So that's those ones done. These ones were kind of nice because their remainder was always 0. They perfectly divided. We do also have the possibility of having cases where the remainder isn't 0. And looking at those, as we state answers for them, we could state them in very particular ways. So if we had something like, 12 divided by 3, we could simply say that's 4. Boom, done. But if we had something like, you're right, I'll just keep that on there. If we had something like 12 divided by 5, what would that be equal to? Well, if you perform that, that's equal to, 5 goes in there twice, but then there's a remainder of 2. So we can express this as a mixed fraction as 2 and 2/5. And that's what this statement here says, is that we can essentially express this as a mixed fraction. Here's the whole number of times that this divides in, but then we've also got this remainder. So that's just a way to express these ones when there's a remainder that's non-zero. So, with that in mind, give these ones a try, see what happens. I'm going to go right into it. I might not do as many color switchings, and I might not be as descriptive with my process. If you need that kind of description, I'd encourage you to just review what was said for the previous ones and see how those steps parallel for this. So 2x cubed plus, not 2, 0x squared, 3x minus 4, and that's getting divided by x minus 2. I can do that. 2x cubed divided by x is 2x squared. I might just lower this whole thing just a bit, give myself space. 2x squared times x minus 2 is 2x cubed minus 4x squared, and I am subtracting this whole thing. Gives me 4x squared there. Plus 3x. 4x squared divided by x is 4x. 4x times x minus 2 is 4x squared minus 8x. I will be subtracting this whole thing, which gets me 11x. Drop that down. 11x divided by x is 11. Multiply that by whatever I have there. I get 11x minus 22. And when I subtract all that, negative 4 minus negative 22 is 18. So as my final answer for this, I'm going to say that 2x cubed plus 3x minus 4 divided by x minus 2 is the whole part, which is right here. So it's 2x squared plus 4x plus 11. And I'm going to add the remainder divided by that divisor. So plus, the remainder was 18, and we were dividing by x minus 2. And this one is done. I guess we do have to actually state, whoops, just as a reminder that because of this business here, we do need to specifically state that x does not equal 2. And that's that. One more example to try. I encourage you to try it on your own, see what you can do, see what answer you get. I'm going to plow ahead with it now. Wait. X cubed minus x squared minus 7x plus 1. Oakley. 3x cubed divided by x is 3x squared. 3x squared times x minus 1 is 3x squared minus, 3x cubed. Yeah, you're right, just rewrite that. Minus 3x squared. When I subtract that, x squared minus 3x squared minus negative 3x squared is 2x squared. Not gonna lie, I actually don't like writing these arrows. I find they clutter things. So if you don't want to write those arrows, you don't have to write those arrows. I would actually prefer that those arrows were not there, but they can help just show the process if you want to do that. But those arrows are not necessary, and I really actually just straight up don't like them. Anyways, 2x squared divided by x is 2x. 2x times x minus 1 is 2x squared minus 2x. And I will subtract that. Give myself negative 5x plus 1. Negative 5x divided by x is negative 5. Negative 5 times x minus 1 is negative 5x plus 5. Subtracting this whole thing. Really just 1 minus 5 is negative 4. Get out of here, wayward part. So when stating my final answer here, I'm going to say that 3x cubed minus x squared minus 7x plus 1 divided by x minus 1 is equal to this quotient-y quotient part, which is 3x squared plus 2x minus 5. And then we're going to be tacking on this remainder. You could say plus negative 4 over x minus 1, but it's probably better form to just simply write that as subtracting 4 over, and then that x minus 1. And this is true so long as x does not equal 1. That's that. Let's put a box around that. Polynomial long division. It's a little bit of a doozy. In future lessons, we will be finding ways to kind of speed up this process that we don't have to necessarily take up as much space as this can. To be honest, when I was first learning the various division methods for polynomials, I preferred the long division. You'll be learning a synthetic division, which takes up much less space later on. But as long as you have some way to divide, cool. And I'll probably reiterate that in the next video. Anyways, there is some practice. So give this stuff a go. Really just get familiar with the process of dividing polynomials by binomials specifically. And let me know if you have any questions or comments or concerns, either as a result of watching this video or from doing that practice work. Please let me know, whether that's in class or on Teams. Other than that, happy mathing. And I will see you in the future.